Hello Year 4 and welcome to your Tuesday afternoon science lesson. And today we're going to be continuing with our topic of sound, and we're going to be thinking about how we actually hear sound. So last lesson we found out a little bit about sound, and I'd like you to pause the video now and see if you can finish these sentences. Sound is anything we can, what's the missing word? And sound is made when materials blank. What could that missing word be? So pause the video now and see if you can finish those sentences. So hopefully what you said was sound is anything we can hear, and sound is made when materials vibrate. So we talked last time about vibrations being when things can move or wobble, a bit like when we talked about earthquakes and the ground trembles or shakes. So we said that sound is made when materials vibrate. So I just thought we'd try and remember back to what forms materials can take. We talked about this a lot before Christmas. So what kind of states of matter are there? Again, if you want to pause the video and see if you can remember, I'll give you a big clue. There are 3 different states of matter. What different forms can materials take? Okay, so hopefully you remember these. And I know that we had, in my class, we had some hand signals for these things. So we had solid, and we had solid, and we have liquids, and we had pouring for liquids, and we had gas, which was sort of like particles floating in the air. I think Miss Whitehouse's class had slightly different gestures for that, but perhaps you can remember what your classes were. So materials, these things that are vibrating when we're hearing sound, can take different sorts of forms. And we know that sound is made when materials move or vibrate. But we know from our topic last term that solids, liquids and gases are actually made up of particles, and it's actually those little particles inside the solids, liquids and gases which are the things that are vibrating. So in a solid, the particles, as we know, are quite closely linked together. And we did a bit of an experiment in class where we had children standing quite close together and holding hands, and that's what it's like in a solid. And this means that the vibrations can pass easily through a solid because the particles are quite closely linked. And they pass, when vibrations pass through particles, we call this a sound wave. Now, this is quite difficult to understand. So I wondered if you could think about, have you ever seen anybody do a Mexican wave? Sometimes you see it if you ever watch football matches and you see some of the supporters. What a Mexican wave is you have to wait in your seat until the person next to you stands up and does this, and then you sit back down. So it's like passes round the stadium. That's a Mexican wave. But a sound wave is a bit like that. So a sound wave is when the particle next to, if you're a particle next to you vibrates, and that passes on to you and you vibrate, and then it passes on to the next one. So actually in the air, which is a gas, even though the particles are not linked so closely, vibrations can still pass through them. So let's have a look at a video which explains this again with some more pictures.
Imagine you could see what's happening to the air as Stella hits the skin on the drum. The air is made up of many tiny particles that surround the drum skin. When she hits the drum, the air particles next to the drum skin vibrate and collide with each other. In slow motion, you can see the vibration pass along the line of air particles. It's called a compression wave because the particles are compressed together. Each of these people represents a particle in a solid object, such as a door or a wall. Because they represent a solid, they are in a fixed position and are touching each other. So when a sound makes one particle vibrate, it makes the particle next to it vibrate, and so on. And the sound travels quickly through the material.
So how do we actually know how sound travels? Scientists had that theory that the particles knock together and collide and pass the vibration on, but they wanted to test whether that would still work. And they used an experiment to do this. So they tried making a sound inside a vacuum. And I don't mean a vacuum cleaner here. What we mean by a vacuum in science is a space which has had all the air particles sucked out of it. So there's literally a space with no particles in it at all. So what do you think would happen if we tried making a sound inside a space with no air particles? Do you think we would still be able to hear that sound? We're going to watch the video. So pause the video now and see if you can think about what you think might happen. And then we're going to watch the video so you can see what happens.
The vibration is moving through the air to reach our ears. Sound always needs something to move through. We can show this if we put the clock inside this special jar. But first, the ringing becomes quieter because the clock is now inside the jar. The air inside the jar can be pumped out. The gauge shows that with each pump, more and more air is being removed. Most of the air has now been pumped out. The bell is still ringing, but we can't hear it. As the air is allowed back in, the bell can be heard once again. This shows that sound vibrations need something to travel through. Here, it's air.
Did you guess right? Did you think that would happen where you wouldn't be able to hear it because there were no air particles for the sound wave to travel through? I thought that was quite interesting. Okay, so let's move on to think about how we hear sound. And can you think about which part of your body you use to hear sound? If you want to pause the video, or if you want to just tell me on video, you can now. So I'm sure you all know this, especially because I almost gave it away by pointing at it, but we all hear sound with our ears. And your outer ear, this bit here, is all flappy, so it can catch those sound waves in the air. And you'll often see, if you know someone who's a little bit deaf, maybe a grandparent or something, you'll often see people who are a bit deaf using their hand to try and hear you a bit better. And that's because if you make that space catching the sound waves bigger, then the sound waves that you get catch more of them and you'll be able to hear the sound better. If you try that, maybe when you're just talking to someone in your family today, if you try putting your hand behind your ear, you'll find that you hear the sound louder. It's magic. Also, we know that if we try listening to something with our hands over our ears, it sounds all muffled. It won't work if you're talking yourself with that one because you can sort of hear it inside your head. But if you try getting a brother or sister to talk to you, and if you put your hands over your ears, you'll notice straight away it sounds a bit muffled because those sound waves are finding it harder to get to your ears. But did you know that part of your ear is also inside your head? So this part here is only part of your ear. So here I've got a picture of an ear. I'm not going to talk much about this today, but I just want to show you that actually there is a bit more to it. So this is the outer part of the ear, the bit that you can see. And this bit here is called the ear canal. It's like a little tunnel into your head. And that's the bit that sometimes you might have wax coming out of. And wax is a natural thing. It's just about cleaning that little pipe. So it just pulls all the gunk out of your ear. And then further down inside your head, there's something called an eardrum, which is basically a bit like a drum skin. It's like a thin piece of skin that's stretched across your ear canal so that it can catch those vibrations, and it vibrates when the sound waves come down it. And then there are also some little bones that pass on the vibrations, and there's this weird thing that looks like a snail but it's actually called a cochlea. And this bit here is really important because this here is a nerve which links to your brain. So all of that part of your ear is inside your head. And if any of those parts of your ear are not working, then that's why you might have a hearing problem. You might be a bit deaf if some of those parts are not working very well. So how do we actually hear sound? What is actually happening when we hear sound? Well, if we imagine that we've got a string here on a guitar or one of your instruments that you made the other day, when that string vibrates, it moves and the particles in the string move, but also the particles in the air around the string move, and they start to move, and then they start colliding and bumping into each other, and the vibrations pass from particle to particle in the air, and they pass through the air until they reach your ear. These red things are more particles, so you can see them still vibrating inside your head. And then the vibrations pass along this ear canal to your eardrum, which vibrates and magnifies that sound, makes it bigger. And then your ear, very cleverly, turns that into a signal which is sent to your brain, and your brain hears that sound. Your brain tells you that you have heard a sound. So let's go over that again, because there's quite a lot going on there. So first of all, the string vibrates. Then the air particles near the string begin to vibrate. And then the vibrations pass from particle to particle through the air as a sound wave. So remember we talked about that kind of Mexican wave, that wave of sound going through the air. Then they reach your ear. And that's why making that space bigger means there's more chance of catching more of those sound waves and sending them down your ear canal. The vibrations pass down your ear canal, they go to your eardrum, and then they are sent as a signal to your brain, and then your brain tells you that you've heard a sound. Let's watch a video again to see if that will help clear up and show us about that.
To show you how sound is detected, this lovely lady is going to drive her spaceship into this gentleman's ear. Oh, stop, stop! Don't you think you've forgotten something important? You've got to use the shrinkifier. Honestly. Ah, that's better. Now, we can see that the ear is just the right shape for picking up sound vibrations. Can you put on your special goggles? Good. We can see those sound waves as they come in. They use the air to travel through. And just down there, we can see the eardrum. When sound waves touch it, it vibrates and sends a message to the brain. What's that? You didn't know that's how ears work? Well, you better drive out very carefully, because ears are quite fragile.
So I think that's pretty amazing, especially how quickly all of those things happen. So if I bang on this drum now, immediately the drum skin is vibrating, the particles in the air are vibrating, the vibrations are passing from particle to particle until they hit my ear, and then they're going down my ear canal into my ear and sending a signal to my brain, and my brain's saying, I can hear a sound. But that all happens so quickly. If I beat this drum now, you can hear it. It almost is instant from that making that sound to hearing it. So it's really a very good system. Right, so here, moving on to your assignment for today, you have got 2 tasks to do today. You have got a first task, which is the same for everybody. And this task, what I would like you to do is listen in your house. What can you hear? If I listen carefully now, I think I can hear the washing machine downstairs. So I could type that in. And what is vibrating to make that sound? And it's actually, if you think about a washing machine, it's actually the drum going round and round, isn't it? It's the washing machine drum going round is making that vibration. And that's what's making that sound. What else can I hear? I can also hear people talking. So I can hear some children, talking. And what is actually vibrating when those children are talking? Well, the actual thing that's vibrating is their vocal cords inside their neck. You might want to put that in as well. So you have a listen around your house. I would like you to collect 4 sounds for me and to think about what is vibrating. Doesn't matter if you don't quite know, but you can sort of think about which part of the thing that's making the noise is vibrating. Doesn't matter if you don't know the right words. If you don't know that they're called vocal cords, you could just say their neck, and that would be fine. Okay, so I want some sounds collecting, so listen carefully. If your house is very quiet, which I would find very unusual, you could maybe try moving around it a little bit and see if you can hear things in different rooms. Sometimes if you go closer to a window, you might hear traffic outside. So think about what's vibrating to make that sound. So that's task 1. And for task 2, what I would like you to do is to match the sentences and the pictures to show us what happens when we hear sound. So some people are going to have a task like this, and some people are going to have a slightly different task. So for this one, we've got the pictures showing what happens when we hear sound. This is the same for both of them, actually. So we've got somebody playing a guitar, we've got the air particles near the guitar vibrating, we've got the sound wave passing from particle to particle, and then we've got the sound wave reaching the ear, traveling down the ear canal, and that signal being sent to the brain. So what you've got to do in this task is you have got to find the right description for each picture. So for the first one, I'm going to say, is it air particles around the string begin to vibrate and move to? Is it vibrations travel down the ear canal? Well, it's not that one because we've not got any ear canal in that picture. Vibrations travel as sound waves until they reach the outer ear. Again, we're talking about the ear. In this picture, I really need something with a string or a guitar in it. When a string is played, it vibrates. That sounds right, doesn't it? So then I'm going to type that one into that box. The slightly different task is you have got your sentences written here. So you've got to find the sentence that goes with the picture. If you think it is picture, that with this picture, the second sentence, I'll just make it a bit bigger so you can actually see this. Oops. So you can see the sentences down here. Your eardrum vibrates and a signal is sent to your brain. If you think that's the right sentence, it isn't, then you would type in B in that box. If you think the right sentence is actually A, you would type in A, and then you would go on to the next picture and type in the box that you think is right. So that's it. So remember, there are 2 tasks this afternoon, and you need to submit those to your teacher when you've finished. And I hope you have enjoyed this lesson, and we look forward to seeing all of your work. Bye.